Hey, how are we doing, my wonderful, amazing geometry students? Today's lesson, we're going to be talking about the segment addition postulate. Okay, so biggest thing you need to remember is that when we see AB with a line over it, okay, that means the line segment that have endpoints at A and B. As you can see right here in this picture, it's a segment that stops at both ends. But whenever you see AB and there's no line over it, no arrows over it, there's no ray over it, nothing like that, then that just means we're talking about the distance between A and B. So now we're not referring to the name of the segment, we're referring to how long it is. Okay, so when we say AB, we're talking about the distance, so that has an actual value. AB equals 14 centimeters. As opposed to if it having the line over it, that would just be naming it as AB the segment. Okay, so something to be aware of, different in notation for the value of a segment and just naming the segment. Okay, so it's important to understand that right here in this picture you see E is between C and D. So when you see E is between C and D, we know we can draw a segment that has E in the middle of the endpoints C and D, somewhere on the line. Okay, G is not between C and D because it's not on the line. So for one point to be between two other points, the 3 points must be collinear. So again, that's one of our vocabulary words we've talked about in the past. That just means they all are on the same line, collinear. All right, so if Q is between P and R, then PQ plus QR equals PR. Okay, and I'll draw a picture of you right here. So let's draw a picture of Q between P and R. So first let's draw point P, and point R. And again, if we say Q is between them, then that means it's collinear with them. So Q is somewhere in here. It doesn't have to be the exact middle, but it's somewhere in between P and R. So now we can see that PQ is this segment right here, and QR is this segment right here. If we add those two together, we get PR, which is the whole thing. That's the segment addition postulate. Pretty common sense. One part of a segment plus the other part of the segment is going to equal the entire segment. So let's use the segment addition postulate right here to do example 1. So N is between L and P. So first we need to draw that. So we need to draw point L, and we need to draw point P. And we know that N is in between those somewhere. I'm not sure where. Let's just put it here. So N is between L and P, and we're told that LN, remember that doesn't have a line over it, so we're talking about the distance now. The distance of L from L to N equals 14. So right here we can label this segment as 14. That's from L to N. And it says PN is 12. Remember, PN is the same thing as NP, so we would call this part 12. And they want us to find LP. Well, LP is the entire thing, right? So the segment addition postulate tells us to add one part of the segment plus the other part of the segment to equal the whole thing. So we're going to say 14 plus 12 equals 26. You add the two parts to get the whole thing. All right, let's do one more. So Q is between RT. Actually, I'm going to go ahead and pause the video, let you guys do example 2, and I'll tell you the answer. So go ahead and pause your video and give it a try, and then you can play back and see how you did. Alright, so you can see right here it says Q is between R and T, so we put RT and we put Q in the middle. Alright, now this is a little different because they tell us that RT, which are the two endpoints of the segment, is 18. So in blue here you can see we labeled from R to T 18. And QR is 10. So this time they give us a piece of the segment and the whole thing. And they want us to find QT, which is the other piece. In example 1, we were given the value of each piece, and we had to add them together to get the whole. Well, now we're given the whole and one piece, and we need to find the other piece. Okay, so common sense tells us that if the whole thing's 18, right, and one part is 10, then the other part must be 8. It's 18 minus 10 is 8, right? So it's just simple subtraction take the whole thing, subtract one part, and it'll give you the part that's left over, 8. So QT's got to be 8. All right, so example 3. Given that AC is 39 and B is between A and between AC. So let's draw that first, B between AC. Sometimes they can word them differently. So it's important to understand what they're asking here. So B is between AC. And it wants to find, see, AC is 39. So let's go ahead and label the whole thing. That's 39. I use these braces right here to try to encapsulate the whole segment. So you can do it either way you want to do it to make sure you understand you're talking about the whole thing. B is between AC. Find BC if AB equals 2x minus 8. And BC equals x plus 17. Okay, so now we've got some variables thrown in. So again, we're still going to do the same thing. We understand that with when we're talking about these segments, we've got two pieces, right? We've got AB and we've got BC that have to add up to equal the whole thing. Okay, so whatever expression we have for AB, we're going to add that to the expression for BC to equal the total, whatever the expression is for the total. So we've got 2x minus 8. We're going to add it to the expression for BC, which is x plus 17, and that should equal the entire segment, which we're given 39. Okay, so you add the two parts together to equal the whole. That's what you always want to think about is what are my parts and what is the whole. Add the parts to equal the whole. So then we've got an equation to solve. So we got to remember how to solve equations. So I'm going to draw a line down the equal sign in order to separate my two parts of the equation. On the left, we need to combine everything that are like terms. Okay, 2x, and do we have any other x's? Yeah, we've got plus 1x. Okay, so 2x plus 1x is 3x. They're on the same side of the equal, so we just add them together. Then the other terms we have are minus 8 and positive 17. So we need to combine those. Negative 17 positive 17 minus 8 is going to be 9. And then over here we still have equals 39. Let me scroll down. Maybe. Okay, now I've got enough room. Let's just put it up here. So I'm going to just rewrite the rest up here. 3x plus 9 equals 39. And then we'll solve from there. So next step is to combine like terms that are on opposite sides. Everything on the left side is combined together. But now we've got a positive 9 on this side and a 39 on the other side. Okay, well, whenever they're on opposite sides of the line that we drew down the middle of the equal sign, you've got to do the opposite to move one across. When they're on the same side, you just combine them together, just add them. But when they're on opposite sides, you got to do the opposite. So this is plus 9, we're going to minus 9. So when I minus 9 from positive 9, those cancel, leaves 3x. And I got 39 minus 9 is 30. And then last, we got 3 times x. Again, it's on opposite sides, so you got to do the opposite. It's 3 times x, so we need to divide by the 3. And then 30 divided by 3 is going to give us 10. So we find x equals 10. But what's the question asked? The question says to find BC, not x, okay? So once we know x, we've got to take it and plug it back into the expression for BC. Well, what was BC? BC is x plus 17. So now we know that x is 10. So we're going to take 10 and plug it back in for x, and 10 plus 17 is 27. So BC we know is going to be 27 units long, whatever those units are. It could be inches, feet, whatever. All right. So let me go ahead and erase this and we'll go on to the next one. Okay, feel free anytime during the video to pause if something doesn't make sense and ask questions. Okay, don't just watch through it and be lost. Raise your hand, I'll come around and help you. All right, so right here, let's find Mn if n is between m and p. So let's draw the picture first. N's between m and p. Somewhere in there. Okay, and we're told Mn equals 3x plus 2. And Np equals 18. This part's 18. And MP, the whole thing, is 5x. Okay? So again, you want to do a part plus the other part equals the whole thing. Okay, so take one part, add it to the other part to equal the whole thing. So what is one part? Well, MN, that's a part. So we'll say 3x plus 2 plus the other part is 18 equals the whole, which is 5x. Okay? It doesn't matter where the x's are. In this one, the x is in the whole. Okay? There's a variable in the whole. In the last one, the variable was just in the two parts. Okay? So it could be different. It doesn't always have to be the same way. So now we're going to draw a line down the equal sign. And again, on the left, we need to combine all the like terms. We've got a positive 2 and a positive 18. So you can combine those together and get positive 20. Now we need to combine terms across the line, right? Because we've got a 3x on one side and a 5x on the other. So remember, if they're on the opposite sides of the line, you do the opposite to move the other one over. This is a positive 3x, so we need a minus 3x. And we're combining terms, we're either adding or subtracting. So those will cancel, leaves 20. 5x minus 3x is 2x. And then to get rid of the times 2, we divide 2. So x is going to equal 10. Now we got x equals 10 again. But what's the question? Because it wants to find x. No, it says find mn. Always make sure you find what it's asking for. Mn. Well, mn is 3x plus 2. So we need to take x, which is 10, and plug it in for x. So mn is going to be 3, and x now we plug in 10, put it in parentheses, plus 2. 3 times 10 is 30, and 30 plus 2 is 32. So now we're not solving, we're just evaluating. We're figuring out what that equals when we plug in 10 for x. 3 times 10 is 30, plus 2 is 32. So our answer is mn is equal to 32. All right, let's do a couple more, and then I'll let you guys practice some. So assume B is the midpoint. So this one's a little bit different. Okay, so we're using the new vocabulary term midpoint right here, which means it's in the middle of the line. Okay, so if B is the midpoint of AC, then that means the two segments, the two parts, have to be equal. Okay, if it's the midpoint, those two pieces have to be equal. So that's how we're going to set up our equation this time. We don't have to use segment addition. We don't need to add them together. When it's the midpoint, we just equal them to each other. So we'll say 3x plus 4 equals 5x minus 6. Because if B is the midpoint, this distance should equal this distance. They should be the same as each other. All right, so 3x plus 4 equals 5x minus 6. So I'll draw a line down the equal sign. There's nothing to combine on the left side, and there's nothing to combine on the right side, because those two terms are not alike. But we do have like terms on opposite sides. So let's combine the x's first. We've got 3x and 5x. We've got to move one of them across. Okay, so we do the opposite. It's positive 3x, we're going to minus 3x. We could minus 5x, that would be fine also, except it would give us a negative, and so we try to avoid negatives if possible. So we got 5x minus 3x is 2x, minus 6. Now we need to combine the minus 6 and the positive 4. So we would add 6 to move it across because it's on opposite sides of the blue line, so we've got to do the opposite to move it over. So 2x equals 4 plus 6 is 10. And then we would divide 2. So we get x on the right side, and on the left we got 10 divided by 2, which is 5. Okay, so if x equals 5, they want us to find the length of AB. So AB is this part, right? Well, once we know x, we can just plug it in. So I'm going to say 3. AB is going to equal 3 times x. X is 5 we found. And I'm going to add 4 because it's 3x plus 4. So 3 times 5 is 15. And 15 plus 4 is 19. So AB equals 19. That would be our answer for number 5. All right, so I'm going to go ahead and pause the video, see if you guys can do number 6 by yourself, and I'll go over. All right, so this is what our line should look like, our segment should look like, because it tells me that B is the midpoint of the segment AC. So B should be right in the middle of AC since it's a midpoint. They want us to find AC, which is the whole thing. If AB equals x plus 6 and AC equals 3x minus 31. So the whole thing is 3x minus 31. Now, if you had a little bit of trouble with this one, it's a little tricky because you say, well, if B's a midpoint, but we don't know anything about BC. They didn't tell us anything about BC. How are we supposed to, set anything up? Well, remember, B is a midpoint. So if B is a midpoint, that means that whatever this piece is the same as this piece. Okay? So if AB is x plus 6, that means BC has to be x plus 6 also. Because they're the same. B is a midpoint, so those two pieces got to be equal. So whatever expression we use for one, we can use the same thing for the other. Now we can do our segment addition postulate by adding up the two pieces to equal the whole, adding up the parts to equal the whole. So I can say, all right, we'll do x plus 6 plus x plus 6, because those are my two parts, equals the whole thing, which is 3x minus 31. All right, and then we're going to combine like terms on the left, because we've got an x and an x, so that gives us 2x. We also got 6 and 6, which gives us 12. 3x minus 31. All right, now we've got to combine across the line, so I'm going to subtract 2x from 3x. Bring down your 12. 3x minus 2x is just 1x minus 31. And then to get the x by itself, we should get rid of the minus 31, so we will add 31. Add 31. So x is going to equal 12 plus 31, which is 43. All right, so if x equals 43, now remember the question says to find AC, right? Well, the expression for AC is this. So I'm going to take x, I'm going to take 43 and plug it back into this. If AC equals 3x minus 31, then I'm going to replace that x with 43, because now I know x is 43. Alright, so 3 times 43 is 129. Probably have to use your calculator for that one, that's alright. Minus 31. So 129 minus 31 is going to give us 98. Alright? Yeah, 98. Alright, so that's all for segment addition. If you have questions, again, feel free to let me know and go ahead and practice.